Standard 11 Chemistry, Unit 4, Chemical Bondings and Molecular Structure, Part 13. Today we are going to learn about atomic overlap concept. As we have already discussed about the shape of orbital, as orbital having spherical shape. So here in hydrogen molecule, it is formed by two hydrogen atom. Here its electronic configuration is 1s1. So here in 1s1 orbital unpaired electron. So as orbital having spherical shape, they are partially interpenetrate. They are partially interpenetrate, and the merging of these two orbitals, and it is called overlapping of atomic orbital. That results the pairing of electrons. Means here the hydrogen having single electron and they are paired. Okay, so here the two atoms are so nearer that their atomic orbital undergo partial interpenetration. And this partial merging of atomic orbital are called overlapping of atomic orbitals. That results the pairing of electron. Here greater the overlapping, means here is called overlapping of orbital. Either here if s orbital having spherical shape and the p orbital having dumbbell shape, and they are overlap. So greater the overlap, stronger the bond form. Stronger the bond form between two atoms. Here in hydrogen molecule, the single electron, they shares the electron, and here the single bond, that is covalent bond, is formed. Okay, so this bond is much stronger. So greater the overlap, stronger the bond between two atoms. Now the overlapping of atomic orbital. uh, Now p orbital and its shape is dumbbell shape. Here this dumbbell shape. Now its sign is positive and the negative. This positive and the negative sign, it is not the charge, it is the sign of orbital wave function. Sign of orbital wave function. Here is the wave function, positive and the negative sign is crest and the trough. The crest of electron wave is positive sign and the trough of electron wave is negative sign. Okay, so here the positive and the negative sign that represents the orientation of orbitals. Now let's see about the overlapping of atomic orbitals. Here is the p orbital and its sign is positive and the negative sign. Another p orbital is overlap. Here is the overlapping of p orbital and the sign is positive and lower lobe, it is upper lobe, while this lower lobe. In lower lobe there are positive sign and in lower lobe is negative sign. It's called overlapping. Here either in z direction, here suppose is in z direction, so overlapping of is called sidewise end to end overlapping. It is called end to end overlapping. And it is called sidewise or side by side overlapping. Here the positive charge, sorry, positive sign, or here the negative sign. Overlapping of p orbital. Or the third possibility is here the overlapping in p orbital, or here the positive sign, it is negative sign, this s orbital, positive sign, sorry, z axis. So this kind of overlapping, and their overlapping may be positive, negative, or zero, that is depending upon the sign, depending upon the sign. Orbital of two atoms come closer to form bond. Their overlap may be positive, negative, or zero, that depending upon the sign. Now the another word, that is phase, and the direction of orientation of amplitude of orbital wave function of orbital wave function in the space. Now the positive overlapping, the positive or negative sign on bonding surfaces, the same sign here, same sign, that means positive or positive sign, or negative sign, and the orientation in space of orbitals. For example, here suppose in pz orbital, is the it is pz orbital, and its sign is positive, and another pz orbital, here positive and the negative. Here the bond is formed by the overlapping of the positive and the positive sign. The bond is formed, and this bond is sigma bond is formed. Suppose in second case is either is pz and the s orbital, positive and positive, okay, or in third case either in px 2px orbital are overlapping. Positive and positive, and here the positive sign, the bond is formed. Means here if the positive overlapping is occurs, they are called bonding. And now the negative overlapping. Negative overlapping means here, for example, pz orbital. Here in this case is pz orbital, and the another pz orbital, but now its sign is opposite, it's positive and negative. Here the negative and positive, so this the opposite sign, opposite sign, and because of this here no bond formation. Whenever the positive lobe and the negative lobe are merging or overlap to each other, there is no bond formation, because here in px orbital the overlapping of here in positive sign and this negative sign, the here the negative sign and the positive sign, here in no bond formation. Or in py orbital, positive negative or negative positive, here the no bond formation. It means here in opposite side that possessing orbital developed energy, the opposite side that possesses orbital developed energy increases, the bonding is not formed. Means here the if negative overlapping non-bonding. Okay, and the zero overlapping is here there is no overlapping. Here suppose is positive and positive, p orbital and p orbital. This no overlapping, positive negative, means no bond formation. Okay, this is the concept about the overlapping of orbital. Now the significance of positive and the negative sign. First of all, the orbit overlapping is takes place or not. Overlapping takes place or not. Second is the energy of the systems increases or decreases. Energy of system increases or decreases. Third, the bond will form or not. That means here if positive lobes, the bond is form, means positive, or negative lobe also bond formation. But if positive and the negative overlapping is no bond formation. Okay, and the fourth is the information that geometry of molecule and the bond angle is formed in the molecule. So this is the concept about the overlapping of orbitals. Next time we will discuss another topic. Thank you very much.